Hello everyone and welcome back to my YouTube channel. So in this tutorial I'm going to show cartoon disease prediction using Pytorch. Pytorch is a machine learning library which is actually developed by Facebook AI Research Lab. And this library is basically used for computer vision, natural language processing, and so many machine learning and deep learning tasks. So this is the application, and this application basically developed by using Flask. So I'm going to click here, choose, and choose a picture. And this picture is labeled by disease cotton leaf. Okay, opened, and I'm going to click here to predict. So you can see here result is disease cotton leaf. So let's choose another picture. Let's say fresh cotton leaf. Let's choose this one and predict. So now you can see here fresh cotton leaf. Again, I click here to choose and go here. Let's choose this one. This is the fresh cotton plant. I'm going to click here open and predict. So you can see a fresh cotton plant. I'm going to click here again and go here. Let's say disease cotton plant. Choose this one and predict. So now you can see here disease cotton plant. So in this tutorial we are going to make this one. So let's get started. So now we are going to install Pytorch in our local machine. So you need to go on your browser. So in my case is Firefox, and click here for the search box. So Pytorch, this Pytorch, and enter. So it will open this Pytorch web page. You can see here this is the web page of that Pytorch. You click on here. So this will open this Pytorch official website. Okay, so you can see here. So let's click on get started. So now you can see here start locally. So now we can see Pytorch build stable and the preview nightly. So I am using pip, yep, and also use the Python. Okay, so your OS and iOS is using Windows, and language is nothing but Python. And what about the coda? So just open your command prompt and type here a command nvidia smi. So it will actually give us the coda version. So in my case, coda version is nothing but 11.1. So you can use less than coda version of Pytorch in your local machines. So I'm using Pytorch 1.7.1. Okay, if trying to show it, let's say Python import torch. Let's say torch dot version. So now you can see here I am using 1.7.1 plus coda 10.1. So I'm using 10.1 version, but my coda version is nothing but 11.1. So you can use less than this version. I'm going to click here to close that. So just you need to choose the coda version if you're able to use 10.2. So make sure that you install the NVIDIA coda driver in your local machine before. Then you can use it. For example, you are using coda version 10.2, so you can use this stable Windows. If you're using Windows, if you're using MacBook or Linux, whatever, I'm using Windows. Then if you want to install is Conda, that's when you have an Anaconda Navigator, you can use that, but I don't have it. And I am using by pip, Python, and the coda, that's the coda version 10.2. You can choose that and go down and copy this one and just open your command prompt. Okay, open your command prompt and just paste it here. So it will install this Pytorch library in your local machines. But I'm using 1.7.1. so let's have a look this one. So now you can see here this is the ecosystem, mobile blog, tutorial, and so on. Okay, so if I go down previous TARS version and go down here, so you can see here version number 1.7.1. this is my version. So now you can see this is the coda version actually I installed. I think it's not this is the coda version I used for the Linux and the Windows. Okay, so you can copy this link and paste it on your command prompt, and it will automatically install this library in your local machines. So make sure that you are using Pytorch. Just open your command prompt and type Python, then import Torch and Torch version. You can check it here. I already explained before. So this is the installation process. Okay, so if you face any problem, you can comment below. Okay, then I will try to solve this problem. So let's get started and jump on our code. So the data set we're going to use, that is cartoon disease dataset. So this dataset actually in from Kaggle. So I will put the link in the description. You can also download this dataset from here. So now you can see here there are three folders: test, train, and the validations. So if I click on the train, so now you can see here each folder contains 4 classes: disease cotton leaf, disease cotton plant, fresh cotton leaf, and the fresh cotton plant. So it's also same on the validations, but in test I think there are 5 folder. No, there are 4 folder. Okay, actually the dataset I am going to use, it actually give me the my one subscriber, and maybe he download from this website from Kaggle, but in my case in my test there are 5 folder. Maybe he make this one, so no problem. I'll be explaining why you are using this one. Okay, so this is the summary. So now what we need to do, we need to actually classify the images. This image is a disease cotton leaf, or the disease cotton plant, or the fresh cotton leaf, or the fresh cotton plant. So let's jump on the code. So before jumping onto the code, so let's have a look at the full data structure. So now you can see here this static template is nothing but for the Flask. So I'll be explaining in the next. So now you can see a data folder. You need to also make a folder called data or dataset, whatever. So inside this, if I click here, there are 3 folders: train, test, and validation. So each folder contains 4 classes: disease cotton leaf, disease cotton plant, and the fresh cotton leaf, and the fresh cotton plant. Okay. So this dataset we are going to use, and you already downloaded it from Kaggle, and basically this dataset is provided me my one subscriber named Naveen Kumar, and his dataset you can see here extra folder test data comp file. Maybe he make this one. Okay, so you're going to use this one. So you can see here CNN Python Pytorch. Okay, so I already make the code before, so I'm going to explain this code line by line. So I'm going to click here and type cmd. And let's say Jupyter notebook. So it will open these on my localhost. So now you can see here localhost is opened. So now I'm going to click here CNN Pytorch. So this is the file you can see here. So first thing first, you need to import some libraries. So I will talk about, and I will be explaining the code line by line. So please watch the video till end. So first thing first, we need to import some library. Import OS, because we're dealing with data in our folder. Then we import the Torch and import the Torch vision, and import the NumPy SNP and the matplotlib basically for the visualizations, and the torch.nn. So this nn is nothing but the neural network. That means in this torch.nn there is in the all what do you call neural network functionality on this torch.nn. If you want to use some model, some module, you can import this one. Now you can see here from torch.nn for functional you can import f. I think it's not necessary. From torchvision.transform you can import 2 tensor, because when you actually read the image is nothing but a NumPy array. But in Pytorch you need to convert this image into tensor. So now you can see here from torchvision.utils we are going to import makeGrid. This makeGrid actually help us to make a grid from our picture. Then you can see here from torch.utils.data.data loader, you're going to import the data loader. So the data loader actually is the built-in library in Pytorch. We don't need to put do extra coding to load our data. So Pytorch will actually help us to load our data. From Pytorch.dataset, you can import the image folder. So it will also help us to actually get the actual location of our image. And it will also help us to actually give the class, that's the number of classes in our folder. Then you can see here from torchvision.transform, I'm going to import the T, ST, not T, T. Okay, so exporting line by line here. So now you can see here data date is nothing but data. Okay, you see on my data folder, I mean in my working directory. So there is a folder called data. You can make it a data set, whatever you can. Okay, so we're going to create a list of that, of this data set, and inside this we're going to cart of the 10 of the files, 10 of the what do you call folder. So now you can see here there are only 3 folders. So for example, in our data, if there have a 20 or the 40 number of folder, so it will actually take only for the 10 folder. That's mean first 10 folder. But in our case, just have 3, so you can choose as 3. You can also make it as, let's say, 3. Okay, and it also give you this 3. Then we need to check that how many classes on our folder. That's mean we have in our train folder there are 4 classes. If I enter, so now you can see a task, train, and the validation is nothing but the listing. Okay, actually print this 2 times. Okay, so now we can see classes.os.listed. We make a list of our folder data read plus train. That's mean inside this data we have a folder called train. We need to go here, then create a list for that, and you're going to print the classes. So inside this train folder you can see all the classes is printed here. This is cotton lift, this is cotton plant, this is cotton leaf, and the fresh cotton leaf. So these are all the classes. So now let's have a check how many picture on each class is contained. Okay, so now you can see a number of training example for the disease cotton lift. Inside the disease cotton lift you can see here is contained 288, and this is the some picture which inside this disease cotton lift folder. So let's check it for the all classes. So now you can see here inside this first, okay, for disease cotton leaf you can see here the picture is nothing but 2288 and on the picture here. So this is the data set. So in this program we actually use the train and the validations, and we're going to test our picture using our test folder. Okay, so now you can see here we need to do some transformation, we need to do some argumentation here. So we are going to resize our image by 32. Okay, so image size is nothing but 32. Now you can see a batch choice is nothing but 128. So now the question is batch choice. So if you get any error, let's say Coda out of memory, so you need to reduce the batch size here. If you're using Coda, it's not a graded version, you can use batch size, little batch size, it's better. I'm using 2 GB Coda. Okay, so I think it will work for me. So now you can see here I initialize STAF is nothing but the combination of the mean and the standard deviation. It actually help us to normalize our data in the range of -1 to 1. Okay, so now you can see here I actually track the folder from our train. So data plus train, it will actually help us, this image folder actually help us to actually get the classes or images from our train folder. That's mean inside this train folder how many images here, we're going to guess that. So train, inside this train you're going to do the transformation of that. See, if you do many transformation, you need to put here t.compose. So t is nothing but the Torch Vision dot transform. If I go up, you can see here Torch Vision dot transform as t. So this is the t. Okay, so now you can see here if I go down, we're going to resize our image by 32 by 32 pixel. Okay, height and width, and the center crop is nothing but 32 again. Actually we initialize the image size as 32, and we need to make our image in 2 tensor. I already discussed about that Pytorch actually accept the image in a tensor format. Then we need to normalize our data in this variation. That's mean why star, because we need to do the same thing on our all of the picture inside this train folder. That's mean inside our train folder there are 4 classes, so it will do the same thing for the normalization of the data. Okay, so you will do the same thing for the validation because you're going to use the validation data. Okay, enter. So now what you need to do, you need to load the data, so using the data loader. If I go up, so now you can see here you're importing the data loader from the utils.data.data loader. You can import that data loader. Okay, if I go down, enter, so now you can see this shell is executed. So in order to show the images in a grid format, we need to denormalize our data because we already normalized our data before. So that's why I am defining a function called denorm. Okay, so this denorm function actually take the image tensor and it will multiply by the image tensor by the standard deviations and the plus of the mean. And I defined another function called show images, and it also take the images and it will create a subplot in a 8x8 pixel by matrix. That's mean in a matrix format. Then I give here a IM show. So this IM show take the images and the number of rows. So now you can see here we denormalize our data, image.dex and the number of maximum images here, and dot permute 1 to 0. So why we need to put here permute 1 to 0? So if I trying to print the image ds, the first number of images, and it will give us the image and the label. And if I trying to show the image, so the image is nothing but a tensor. So if we're trying to print the shape of that, so let's say shape. So now you can see here image shape is nothing but 3, 32, 32. So 3 is nothing but our channels. But in Pytorch, channel in the first positions. So you use a matplotlib to show these grid. So that's why you need to actually do the permutations. So the permutation actually help us to go this what we call channel in the last, and it will give the weight in the first position and this height in the second positions. Okay, so it is so easy. And you also put here show batches function. Okay, so now you can show batches, so it will actually load in the batches of the images. Again load, and now you can see here show batch train dl and the torch.coda empty cache. So why I need to put here coda.empty cache? Because how you actually load all the library in our Pytorch is basically use the coda, and sometimes the RAM is full and we need to empty the cache. Enter. So now it will load it in a few seconds. If I go down, so now you can see here there are batch of images. Okay, batch of images. So if I try to do it for validation data, so now you can see here it also same for the validations. Okay, so now we define an image classification base. So this base is nothing but take the nn.module. That's been from the neural network module it actually uses. So we define a function called training step to actually return the loss, and this will give us the loss of the validations. Okay, and this will give us the validation epoch and, okay, the combined accuracy and the combined loss, and it will give us the epoch and this will give us the accuracy. So this is the base class. Okay, so don't worry on that. I'll be put this code in a GitHub link, and there should be a password, and the password name is chandu.123. So if I go down, so now you can see here we define our model. So let's execute it. So now you can see here this is our model, class CNN model, and it will inherit all the functionality from the image classification base. So now you can see here we defined, okay, we defined a network called nn.sequential, and you can see here all the layer is defined one by one. So now you can see here first convolution layer, we initialize the first convolution layer. It will take the number of channel and 3, and it will convert this channel by 32. And this 32 actually now you can see here 3, 32, 32. Right now is the channel is nothing but 3, and the 32, 32 cross 32 is nothing but our size of the images. And we are going to convert this channel by 32, and the making the that's in channels at the 64, and we will give here the max pooling. So this time the max pooling is divided by our pixel, that's been original pixel, by 2. So that's mean 64 is nothing but our pixel, and 16 that's mean we divided this original pixel, that's mean 32, so we divide this by 2, that's means 16. And again initialize a layer 64 and the channels, and it will convert this channel by 128, and again, and we put here a max pooling layer, that's mean it will convert this 121 channels, and again 16 divided by 2 equal to 8, and we'll do the same thing for the this one. So 256, that's mean 256 divided by 128 cross 2, that's mean 256. If I go up again, so now you can see here 32 cross 2, that's mean how we apply the max pooling, it will cross that, that's mean 32. Okay, so if I go down, now you can see a 32. Okay, 32, that is 64 cross 2, 128, and this one 256. And if I go down here, we initialize a flatten layer. So this flatten actually give us the vector of this layer. Okay, so we put here the vector in our linear model. Okay, so nn dot linear 256 comma 4 comma 4, we are going to convert this 256 comma 4 comma from into 512 channels, and finally we are going to convert this channel into we give here a non-linear activation function and under ReLU, and nn dot linear, we put the channel into the linear, and you're going to put here 4. So the 4 is nothing but the output feature of our model, and we give a gradient, we give a forward. This is the forward function, and this will help us to actually forward that. Enter. So it will execute it. So define the model. So model is nothing but the CNN model. So now you can see our architecture of the model. This is sequential. Sequential means it will pass the data into one layer to another layer. So if I try to show the images, for images or levels, it will help give us the shape of the images. So now you can see here 128, 3, 32, 32. So 132 is nothing but our batches, and the size is nothing but 120 watt, 4, and the 4 is nothing but our output classes, and this is a tensor, and this is the output print, and it will give a grad function and select backward. That's mean the backward function it executed. That's mean gradient our calculated. And now we define two functions and one classes. This is the get default data. If you have a coda is available in your local machine, it will give you the coda, otherwise it will give you the CPU. And to device, it will actually help us to train our model in our devices. And this is the data loader. Okay, and this is the class for the device data loader. So enter. So now you can see here sorry, our device type is nothing but coda. So I am using coda version 10.1. I already see you before. So now we need to load the data in our device data loader. That's mean using the coda we actually train our model. If you have CPU, it's not a problem. Okay, enter. So it is loaded. So now you can see here we define a function called evaluate. So it will take the argument as model, that's our model, and the validation data loader. So using this evaluate, okay, we actually calculate the loss, how many losses our model is overfitted or not. So it will give us all the information here. So now you can see here I define a function called fit, and it will take the argument called epochs, learning rate, model, train loader, validation loader, optimizer function, that is torch.optim.sgd. Okay, so this is a optimizations optimizer. Okay, then you can see here we actually define a list, okay, history, and you can see optimizer.optim function, that's optim func. This is the what do you call this, is a function, and it will take the argument as model.parameters, that means parameter of all the models here. If I go up, so this is the all parameter of the model, that means our network. Okay, and to put here the learning rate, initially learning rate is 0.001, and you can also a technique called one circle learning rate. You can also use this one, but in this case I am just using a constant learning rate 0.001. And now you can see here we actually create the epochs, and it's the training phase, that's the model we are going to train that. We're going to calculate the loss, that's why we are going to create an empty list, and we are going to load all the images from the data loader in a batches, and we're going to calculate the loss, and we're going to append the loss in our training losses, and we give here the backward, that means we are going to calculate the gradient, then optimize the step in the each gradient of the epochs. Each epochs we are going to decrease the losses using the optimizer, and again after calculating that we need to give here optimizer.step grade. That's means we're going to remove all the value from the optimizer, then again we're going to epoch. That's means for each epochs it will actually calculate the loss, gradient, and the other things. Okay, so now you can say for the validation phase you're going to calculate the result. That's mean it will actually help us to actually give all the training losses or the validation losses. Then you can see on the graph this is our model is overfitted or not. Okay, so enter model equal to 2 device. We need to put here into model in our devices. First we are going to evaluate, then we need to initialize the number of epochs. So right now you can see our initial number of epochs is nothing but 8. And optim function, you're going to use the optimizer atom. Okay, this is the atom optimizer function. But if I go up, now you can see here for the, but if we don't put any optimization function, it will actually initially take the stochastic gradient descent optimizer. But we put here the optimizer as a atom. Okay, so now it not actually take the stochastic gradient descent, but in CNN atom we will best. Okay, so now you also calculate the time, how much time it will take to train the model, and you call the fit. We define the function before, so enter. So it will take maybe 3 or 5 minutes to actually train the model, and you can also see the time. Okay, so now you can see here epoch is nothing but 0, and the validation accuracy nothing but 0.1973, and the loss is nothing but 1.3640. And actually I already trained this model before and I got 93% accuracy, and you can also use this model, but this time we need to also train that, and let's see how much accuracy it will actually give us. Okay, so I'll be pause the video here, it's better. So now you can see here it got 83% accuracy. So if we run this code again, I think we get 95% accuracy. Okay, let's try it out again. So when we train the model again, okay, so now you can see we get 92% accuracy. Okay, so if we're trying to plot the accuracy, okay, so now you can see here, if I go here, so first time accuracy is up, again up, again up, but this time is down, again this time down, that's been again up. And if we're trying to show the losses for the number of epochs, so right now our model is trying to overfit it here. Okay, so this time is not good, but the difference is very high here, okay, for the training and the validations. But this time, for the last epochs, right now our model is trying to predict very well. Okay, so now load some data from our test data. So you need to do the same thing before, or you do it before. For the image folder, you're going to iterate to all the value. For the task transform, you do the transformations. We do it before, resize, center, crop, and we need to also convert our image to tensor, and to define a function called predict image. And to take the image and to unsequence them. Okay, that's mean we need to convert the image into batch 1, because we actually load only single number of images. We not actually get the 120 images. So that's why unsequence 0. That's mean it will actually take number one batches, and we give this image or the batch of the images in our model, and it will give us the predictions, and we are taking the maximum, and it will give the classes from our data sets. Okay, so this is the nothing but the data sets, and these data sets actually help us to give the classes. Okay, enter. We're going to save the model, and let's say make this one cotton, let's say demo. So now you can see here model demo.pth, but in TensorFlow you're using AS5 or dot model, but in Pytorch you need to put here .pth. Okay, so let's say for this one. So now you can see here label is nothing but the disease cotton plant, and it also predicted as disease cotton plant. That's mean our model worked fine. So if I try to see for the first one images, so now you can see a disease cotton leaf and the predicted output is nothing but the disease cotton leaf. That's been our model working fine, man. So now it's time to actually make our web application using Flask. So before jumping on the web application code, we need to actually make our cache empty. So you can see here torch.coda.empty cache. So it is loaded. So this empty cache, it actually helps us to empty our cache in our coda, inside our coda, because we train our model, we load we are importing so many files, so many libraries. So that's why our aim maybe it failed. So that's why we need to empty the cache here. Now you can see here this is our folder structure as you see before. So now you can see here a Python file, app.python file, py. So if I go on the templates, now you can see here there are some HTML document. And if I go here, the static is nothing but contain the CSS and the JavaScript. Okay, so don't worry, I'll be put all the code in my GitHub. You can grab that. And I'm going to click here with open code and click on the app.py. So now you can see here actually imported all the necessary library. Okay, so now you can see here import Cs as we import in our Jupyter notebook. But you can see here there's some library is new here. And then again you can see a torch or AutoCAD.variable. We need that. And also you can see here from field we are going to import the images because we are loading the images. And you can see here the Giband. This is actually the WSGI server. You need to also install this Giband. So just open your command prompt and again type pip install and the library name and enter. So it will install this library, and you need to also do same for the workjack and the Flask. So now you can see here you input the Flask and the redirect and the URL for and the request and the render template. So now you can see here we actually defined our data div and the image size and the external divisions in our Jupyter notebook and also the loader. Okay, so this also load the loader from our training, and we need to also actually classify. We need to put here also the image classification based. It will actually extend the another module. You need to actually give all the things here, because when we load the Pytorch module, it would actually need that. But in TensorFlow, you don't need that. Okay, so class CNN module, you need to just copy all the code from your Jupyter notebook, and also the get devices, to devices, and also the predict images, and now you can see here image loader. Okay, so this is the another functions. So now you can see it will actually help us to load the images. So from using the pill, so the pill is nothing but pill, and we are going to load our images, image.open and the image open, and we are using the loader. So if I go up, you can see here this is nothing but the loader. So this loader actually help us to actually resize our data in our particular architecture, because we train our architecture using 32,32, and we also import the data set. This data set, inside the data set folder we have the classes. We are going to actually extract the classes from our 10 folder. Now you can see CenterCraft to tensor. Actually I'll actually explain all the things before, and go down here. Okay, so now you can see two devices, and this one for the two devices for the predicting images. So now you can see two devices and the unsequence. That's when you can say convert to batch of one. I already said before. Okay, and it will the prediction from the model and the pick the index from the highest probability. I already told about that, and then retrieve the classes from the labels. And this one, the image loader, you can say loader that floating, and again it will take the image in the variable, and it will take the image by a coda. And now you can see here actually initialize our model. So model is nothing but from the two devices. That's mean it will give the model in the two devices, and the CNN model and the get default devices. That's mean our default device is nothing but coda. And we're going to load that state dict and the torch load another model cotton file. This is the file actually I created before. So now you can see here cotton demo. This is also the model file, and this model file is before I trained the model. So now you can say we can use this cotton demo. You can use that, and now you define our app function. This is the nothing but the route, and you take the get. This method is nothing but the get, and it will give us the initial web page, the index.html. And when we click some button, and it will predict it. That's when we actually click on the predict button. If I go on the templates on the index, so now you can see here this is nothing but the from. So this from is nothing but for choosing the images, and this the input type is nothing but the file, and this is the image section. That's mean it will actually give us the section of the images, and you can see this is the loader, and this is from the bootstrap, and this will give us the image result. Okay, so if I go here, now you can see how we actually click on the prediction button. Okay, so that's mean the predict button here, this one type is button and the button primary, and the type is nothing but the predict. So how you actually click on this predict button, and it will go here, and it will say that if you click here, then that number slash is nothing but the predict, and the method is nothing but the get and post method, and we upload the images. That means this is the post. Okay, so we get the file from our post request. Okay, then we are saving the file into our upload folder. So now you can see here upload folder. Okay, uploads. So you need to create this upload folder before. So we save the file inside our upload folder, then you can make the prediction from our upload folder. So image loader and the file path. So this image loader actually help us to load our image, and using the image loader we can resize, compose, or what you call normalize, whatever you can, and it will finally give me the predictions. And this is a predict image. This is the define function. I defined the function before. I take the argument at the image and the models, and it will return the prediction and return none. Okay, so this is the code for the Flask. Don't worry, I'll be put all the code. The main thing is that is if you understand the model, or how can you code on Pytorch, so it is actually easy to actually build the model. Then you can copy the code. This for the Flask, it's not necessary, but the main necessary things is if you are able to know the technique of deep learning, if you are able to know how can you load the data using Pytorch, if you know about the how can you actually convert the image in a tensor, and how can you know how can you actually create an architecture. This is the thing. Okay, so now it's time to actually what do you call, run our code. So I want to click here to terminal and new terminal. So let's say python app.py. So it will open in your local host, in your local browser. So now you can see a restart with Windows API reloader. So follow link. Click here to choose the images. So this is the test folder. Okay, so let's check for the disease cotton, this kind of click. Let's use this one, and enter for the predict button. So now you can see here disease cotton leaf. I'm going to click here to choose. Okay, let's show fresh cotton leaf. Let's use this one, predict. So you can see here fresh cotton leaf, and let's go on this test one. That's this use one. Okay, so now you can see here fresh cotton leaf. So this is the tutorial. Hope you will enjoy this tutorial, and make sure to subscribe my channel, and don't forget to hit the bell icon for never miss an update. And thank you, and bye bye.